Dear students, in this lecture, we will discuss on an important fluid property, that is viscosity. Viscosity is a resistance offered by the fluid to flow or to move. Now let us consider an inclined surface. And now we are pouring two different fluids on this inclined surface. First one is water and the second one is honey. So when we pour water, the water will move along the surface with a particular rate of flow. Next we will pour honey. So when we pour honey, the rate of flow of honey will be very slow. So in case of honey, the velocity will be very less, and in case of water, the velocity will be very high. This is due to the property of viscosity. So it is the resistance offered by the fluid towards movement. So here we can conclude that the water possesses very low viscosity. Thereby it offers less resistance to flow. As a result, the rate of flow of water is high. Whereas honey possesses high viscosity, and as a result it offers more resistance to the movement, and as a result the rate of flow will be very less. We will consider two surfaces. Here the bottom surface is fixed, the top surface is able to move. This is a movable surface. Okay, and now we are applying a particular force in the top surface such that the surface is able to move with a certain velocity v. And since the bottom surface is fixed, the velocity will be 0 here. And now we will fill fluid between these two surfaces. So when we apply a particular force on the movable surface, what will happen? The fluid adjacent to the movable surface will also start moving with a certain velocity v. Whereas the fluid adjacent to the fixed surface will not be able to move. And there occurs a velocity gradient. There will be a velocity gradient between the two surfaces. Here the length of the arrow represents the magnitude of velocity. So here we can conclude that the fluid layers which is adjacent to the movable plate will experience more velocity, whereas the fluid layers adjacent to the fixed plate will experience very less velocity. This is how the velocity profile will be. This is a y-axis, this is a velocity axis. This picture also explains the same phenomenon. So here we have a container. This container is a fixed container and we are applying a force on the surface. Here fluid is filled, we are applying a force on the surface. So those layers which are adjacent to the movable surface will experience greater velocity, and when we go down, the velocity will keep on decreasing. And this phenomenon is explained by an important law in fluid mechanics known as Newton's law of viscosity. It is explained by Newton's law of viscosity. So here we can calculate the shear stress associated with this applied force. Suppose A is the area of the surface. A is the area of the surface. So the shear stress tau. Shear stress we will usually represent by the symbol tau. The shear stress will be equal to force by area. F is the applied force. A is the area of the surface. Area in plan. The shear stress is given by force by area, and there is one more term, that is velocity gradient. Velocity gradient. Velocity gradient is the rate of change of velocity. So here we can say that V1, V2, V3, V4, V5 are the velocities of different layers of fluids. So there is a change in velocity between each layer. Suppose the change is du. So we can write the velocity gradient as du by dy. Du is a change in velocity and dy is a change in distance. So velocity gradient is given by du by dy. And this Newton's law of viscosity states that the shear stress is directly proportional to the rate of change of velocity or the velocity gradient. And to remove this proportionality sign, we can multiply it with a constant mu. Mu into du by dy. So this mu is known as coefficient of viscosity. Mu is known as coefficient of viscosity. So Newton's law of viscosity states that shear stress on a fluid element is directly proportional to velocity gradient or rate of shear strain. Rate of shear strain is also known as velocity gradient. And this is a velocity profile. Du represents a change in velocity between two adjacent layers and dy is a change in distance. Okay, and we can express Newton's law of viscosity as tau is equal to mu into du by dy, where mu is the coefficient of viscosity. It is also known as dynamic viscosity. Coefficient of viscosity is also known as dynamic viscosity. Now we will calculate the unit of dynamic viscosity. Okay, so from this expression we can write mu is equal to tau divided by du by dy. So now we will first see the unit of tau. Tau is force by area. Unit of force is Newton. It will be Newton per meter square. And du by dy, the unit will be, du is velocity, meters per second, dy is meter. So we can write the unit of mu as Newton per meter square divided by meter per second per meter. So it will be Newton second per meter square. And there is an alternate unit known as poise. So 1 poise is equal to 0.1 Newton second per meter square. Next we will see one more viscosity term, that is kinematic viscosity. It is nothing but the ratio between dynamic viscosity or density of the fluid. It is expressed by the symbol nu. So we can write nu is equal to viscosity or simply dynamic viscosity mu divided by density of the fluid. Now we will see the unit of kinematic viscosity or nu. We know that unit of dynamic viscosity is Newton second per meter square. And this Newton we can express as kilogram meter per second square into second per meter square. And the unit of density rho is kilogram per meter cube. So we can express kinematic viscosity or nu as kilogram meter per second square into second per meter square divided by kilogram per meter cube. By solving, we will get it as meter square per second. And there is an alternate unit known as stroke. And 1 stroke is equal to 10 raised to minus 4 meter square per second. Next topic is classification of fluids. This classification is based on Newton's law of viscosity. Those fluids which obeys Newton's law of viscosity are known as Newtonian fluids, and which do not follow Newton's law of viscosity are known as non-Newtonian fluids. Newton's law of viscosity is shear stress is directly proportional to rate of change of velocity of water, air, petrol are examples of Newtonian fluids, whereas blood, paint, paste are examples of non-Newtonian fluid. And there is another category of fluids such as ideal fluid and real fluid. Ideal fluid is an imaginary fluid. Such type of fluid does not exist in nature, and for an ideal fluid, the viscosity will be 0. And for real fluid, it possesses a certain amount of viscosity. All fluids in actual practice are real fluids. And Newtonian fluids are the one in which shear stress is proportional to shear strain, and non-Newtonian fluids are those in which shear stress is not proportional to shear strain. These are the classification of fluids. Next we will see another fluid property, that is cohesion and adhesion. They both are forces of attraction between molecules, where cohesion is a force of attraction between molecules of same kind, whereas adhesion is a force of attraction between different type of molecules.